Now I'll be looking at an instance whereby diagrams will be used to solve modulo. So let's consider, let's say mod 4. Mod 4 has values 0, 1, 2, and 3. So if you want to use a diagram to represent mod 4, let's assume of a rectangle. So 0, 1, 2, and 3. Yeah. So with this, we go this way, we go clockwise if you have positive numbers, and we go anti-clockwise if you have negative numbers. So let's take an example. Let's say 2 mod 4. 2 in mod 4. So we start from this spot, so we go this way. 2 in mod 4 is, so you are going to count this number. So 1, 2. So 2 in mod 4, the answer is 2. Let's look at, let's say 5 mod 4. 5 mod 4, so 1, 2, 3, 4, 5. So 5 mod 4, the answer is 1. Let's say 7 mod 4. So you're going to count 7 starting from 1. So 1, 2, 3, 4, 5, 6, 7. So 7 mod 4 ended at 3. Let's say 11 mod 4. 11 mod 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 mod 4 is 3. Now, the next thing is, let's look at mod 6. Mod 6 has values 0, 1, 2, 3, 4, and 5. So let's use this to represent mod 6. Let's say 0, 1, 2, 3, 4, and 5. Now when you go this way, we go clockwise when we have positive numbers, and we go anti-clockwise. We go anti-clockwise when we have negative numbers. So let's pick the first example. Let's say 8 mod 6. So you're going to count up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 mod 6 is 2. Let's look at negative 4. Negative 4 mod 6. So for that one, we go anti-clockwise. So 1, 2, 3, 4. So negative 4 mod 6 is 2. Let's look at negative 7 mod 6. Negative 7 mod 6. So 1, 2, 3, 4, 5, 6, 7 is 5. Let's look at negative 3 mod 6. Negative 3 mod 6. So go backwards 3 times. So 1, 2, 3. That's 3. And let's look at a positive number. Let's say 9 mod 6. 9 mod 6. So 1, 2, 3. 9 mod 6 is 3. And let's look at the last example. Let's say negative 12 mod 6. Negative 12 mod 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So negative 12 mod 6, the answer is 0. Now let's look at clock arithmetic or mod 12. Now we are using the face of the clock as a mod 12 because the clock is in mod 12. The clock starts from 0 up to 11, or let's say 12 up to 11. So this portion is 12, but we don't write 12 because mod 12 we don't need 12. Mod 12 starts from 0 and ends at 11. So we are using the face of the clock, and you can see that we have 12 digits here. So with this, let's start with an example. Let's say 12 mod 12. So this one too is the same thing. We go clockwise. For positive integers, and we go anti-clockwise for negative integers. So 12 mod 12, we are going clockwise because this is positive, so we are counting 12 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer is 0. Now the values you see here are the answers we are looking for. All these values are answers, or they are remainders. So that's what we are interested at. The next thing, let's look at 15 mod 12. 15 mod 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 mod 12 is 3. Let's look at negative 10 mod 12. Negative 10 mod 12. Because this is negative, we are moving backwards 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 2. Let's say negative 18. Let's say 17. Negative 17 mod 12. We are moving backwards 17 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we have 7. And let's look at the last one. Let's say 24 mod 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And the answer is 0. So what are we saying? We are saying that given A mod K, we move clockwise if A is greater than 0 and anti-clockwise if A is less than 0. So let's take this last example under diagrams. Mod 3 has values 0, 1, and 2. So let's use a perfect polygon to represent mod 3. We have 0, 1, 2. When you move this way, we move this way when A is greater than 0. So when A is greater than 0, we move clockwise. And we move this way when A is less than 0. That's when you have negative numbers. So for that one, we move anti-clockwise. So the first example, let's say negative 4 mod 3. So we move anti-clockwise 4 times. So let's go. So 1, 2, 3, 4. So the answer is 2. Let's say negative 5 mod 3. You move 5 times anticlockwise. 1, 2, 3, 4, 5. That's 1. Let's say negative 7 mod 3. You move 7 times anticlockwise. So 1, 2, 3, 4, 5, 6, 7. That's 2. And let's say negative 6 mod 3. You move 6 times anticlockwise. So 1, 2, 3, 4, 5, 6. The answer is 0. Now let's consider positive numbers. Let's say 8 mod 3. We are moving clockwise 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. The answer is 2. Let's look at 9 mod 3. We are moving clockwise 9 times. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 0. And let's look at the last example. Let's say 2 mod 3. 2 mod 3. We are moving clockwise 2 times. So 1, 2. So these are few examples under using diagrams to solve mod. You can also go by the remainder theorem in the previous video, or you can use the diagrams to solve mod. But the reason why we don't buy the idea of using diagrams is that when the figures become very large, as in let's say 25 mod 3. 25 mod 3 can be solved. Let's say 25 divided by 3. 3 goes here, 8. 3 8 is 24. So this becomes the remainder. So therefore 25 is equal to 1 mod 3. But if you want to use the diagram, you are going to read 25 times. So let's read 25 times. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, which occurred here, of which you can do it simple, finding dividing this by that. Let's say 25 divided by 3. 3 goes here, 8, remainder 1. This is what you are interested in. So the reason why we don't buy the idea of diagrams is that it's because of this. When the values become very large, when you have large values, you don't need to go by counting the faces, but it is good for you to know that this is what is happening behind the scene. And make sure you solve more examples under these simple problems. Make sure you solve more examples under finding the mod of certain integers, being it positive or negative.